Hello and good morning, everyone. So today I would like to go through a very interesting article by Anthropic, which is regarding building effective AI agents. In particular, what I want to show you is the key difference between workflows and agents. Because what I see right now happening is a lot of people want agents, but they don't really know the power of agents. And most of the time a workflow will actually do. And workflows are way more efficient and predictable. So very often it's actually better to use a workflow than an agent. And so that's why I thought we'll just go through this paper together, and then I'll also ask Luna, a colleague of mine, to give a little bit of a practical demonstration about what I mean. So let's start. Here, I like this definition very much that Anthropic uses. Namely, workflows are systems where LLMs and tools are orchestrated through predefined code paths. And agents, on the other hand, are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So this is actually a very big difference, and for all of you who have been developing, for example, with Make or other automation tools, they were really focused on workflows, right? So a workflow gets you from a certain input to a certain output. And even if you have some LLM steps in the whole workflow, it's still a workflow because it's going from A to B, and there is no way that it will end up at, let's say, Z, right? And so for example here, let's look at when and when not to use agents. So these are a few frameworks, right? I mostly develop with Relevance AI, so I'm not into all the development frameworks, but actually the same basic principles apply. So that's why I like to go and check the documentation of actual people using the various frameworks, because they're really very detailed and the logic is exactly the same, just that you're not handling the code, you're just handling the logic. And that gives you, in my opinion, additional edge to think about, how to structure an agent and what cognitive skills to give it to this agent. And so let's start with this. The building blocks, right, of workflows and agent. So one building block is what we call the augmented LLM, which is, for example, how, very basic structure of agents these days. Because what we define agents as are basically an LLM chain or a node, which has retrieval options for specific knowledge. It has the access to specific tools, and it can also read and write into memory. So it retains context, and possibly this is short-term memory, but you could also give it some long-term memory. And let's go to the actual workflow, right? Prompt chaining. So this would be a typical structure for a workflow, where, as I said, you get from a specific input and a specific point in the workflow, you get to a specific output and end of the workflow. And in this case, obviously, we could have a simple logic where, depending on our condition, we have a pass or a fail. And so if we fail, we'll have a branching logic that kills the workflow. But you see, it's very linear, right? This would be the structure of a typical workflow in Make. And actually, these workflows have become extremely powerful because of LLMs. Like before, they were kind of dumb, right? You could just, based on a predefined set of input, do some programmatic changes and get to a certain output. Now, already with this kind of logic, you have 3 LLM calls. So you can already factor in a certain cognitive ability of, let's say, manipulating in a fuzzy way a certain input. And with fuzzy, I mean that it's not specifically clear, right? That you wouldn't be able to, or it would be very complex to define a specific decision tree where based on X you get Y, and based on, let's say, Y you get Z. But you could just give the LLM a prompt saying, okay, for example, typical use case is email sorting. If you know, spam filters have been very bad at this historically, but now you could just ask an LLM based on specific training to filter out spam email. And maybe at some point you get a email for a new business opportunity about a totally random email, but the LLM actually, with the context, understands that maybe this is not spam and actually sends it to you. And yeah, so you see we get from A to B in a predictable workflow. And I'll just, to demonstrate this, give you, for example, copy this link and give it to Luna and say, hey Luna, can you please give me the key messages of this article? Thank you. And here is the link to follow. And so you see now I'm inputting a request to Luna with a specific link and a specific request, right? To basically extract the key messages. What is now happening is that Luna is powered by an LLM and she has access to certain tools. So what she will do is basically understand this request and think about what the request actually is, and then check at the tools at her disposal, and based on the tools at her disposal, choose the most correct one, and then give me use it and then give me the key points, right? So you see she used this tool, extract content from websites, so scrape the website, and then told me, okay, simplicity is key. Good one, right? It's actually one of the key messages of this paper. Simplicity is key. So agents and agent systems, I see a lot of like very complex solutions that actually don't get anything done, can get very complex very fast. And LLMs tend to lose context if you have, big agent systems. So there is a lot of nuances to be careful of if you build these very big systems, and rather just start simple. So sometimes the simplest solution is the best one, and ask yourself, do I really need an agent? Do I really need a multi-agent system? Or maybe it's just a make automation with some LLMs chained together, which frankly is already very powerful, because you can, with just prompt chaining like this, you can actually create very complex workflows. For example, input a YouTube link, then have a module that extracts the transcript, have an LLM that extracts the key points, and then based on the key points, maybe have a filter that is even an LLM that checks if it's relevant to your brand, and if it is, it will then have another LLM taking your brand voice and reformulating it and then posting it somewhere. Right? This is not an agent, it's just a workflow. There is no decision making, no fuzziness in a way. No back and forth. It's just like, okay, take it, check it, and do something with it or not. A little bit like, most of the things I see. But yeah, this was an example where, in a way, I'm using her and she has additional capabilities, but this would be a request where no agent is needed. I could just have an automation which parses always the link out and knows that when I send the link, it should do a transcription and extract the key points, for example, right? Then let's continue. Workflow routing. So this is one that is more, is more in the area of what we're doing, in the sense that you have an LLM that is the router, which basically based, as I said before, on a certain fuzziness of decision making. So is the content, for example, relevant for my brand, it's difficult to define an on-off logic with that, right? So you could have a router that defines based on that whether the content is relevant, and then call different other LLMs. So if it's super relevant, have a certain process. If it's less relevant, have another process, and if it's not relevant at all, have a third process. This is just a random example I made up now, but this is basically the logic about a router, that you are able to capture a workflow where there's no clear on-off logic, and you need some kind of cognitive power to take the decision for you. And let's see what Anthropic says. Building more specialized prompts without this workflow, optimizing for one kind of input can hurt performance. Yeah, exactly. So you can specialize these specific calls based on a certain decision made by the router. Direct different types of customer service queries. Yeah, so you see, this is the typical use case. For example, like email, where you would have a router understanding what kind of request this is, and then route it either to other LLMs to create a response. So this would be one specialized in, let's say refund, the other technical, the other customer management for general inquiries, or it would even send it to the team directly. Then workflow parallelization. So this is one that actually I haven't been using so much, because as far as I know, there is not a way to do this in Relevance, which would be actually a great addition, especially because I read an article about tree of thought, where it's possible and it enhances results for complex decision making if certain decisions are analyzed in parallel, following different paths, and then aggregated again to kind of put the light on different angles. Like, let's say you want to plan content for a week, you could have a focus on psychological triggers, a focus on brand alignment, and a focus on growth. And if you have specialized LLMs, they will all develop different content, and then you basically combine it. And you could do this, one after the other, but actually sometimes it's better to do it in parallel, because it just, saves time. And then you can aggregate it and get the output. So this is a very good one to keep in mind, which I'm very interested actually to test, but I haven't tested yet. Yeah, for speed, one multiple, exactly. So this one, for example, multiple perspectives or attempts are needed for high confidence results. This is a typical one that I just mentioned. Okay. Okay, so this one is one that we've been seeing a lot, with agent systems. Many times you have specialized agents and one agent basically managing them, and then, doing the work or delegating the work to each of them. And this is the orchestrator workers workflow, where a central LLM dynamically breaks down tasks, delegates them to worker LLMs, and synthesizes their results. So in a lot of agent systems I'm seeing, they're built like this, and they're not really in that sense agent systems, but more, as they mentioned here, basically orchestrator workers workflows, because still they get from a certain input to a certain output with a predefined structure. So often you will see a step-by-step instruction in the orchestrator, where he will tell you, let's say copywriting. First, an agent does the logic, or one retrieves specific brand information, another one creates the logic of a certain content strategy, and the third one does the actual copywriting. So you kind of segmented it down, and then it's synthesized, and you have your final output. And when to use this workflow? Well suited for complex tasks where you can't predict the subtasks needed, encoding, for example, the number of files, whereas it's topographically. Yeah. So this, you see, it's already, suited for certain tasks where there is a certain level of fuzziness, because as mentioned, you cannot predict, for example, how many specific subtasks are needed. As an example with the content, right? If we had, if we had this workflow, it would be very difficult because you wouldn't be able to go back. Like if we had, let's say, the logic and the copywriting here, then if you create one time the logic and then a copywriting, you could create a kind of a loop that is dynamic based on the input, but it gets very quickly cumbersome to manage this in a normal workflow. And so here, we would be actually be able to get dynamically as many or as few requests for content, and then the orchestrator would know the process and kind of dynamically decide how to proceed. And the synthesizer, frankly, I haven't been seeing it so much. Often the synthesizer is the orchestrator, but it's also good to have someone synthesizing again. Then obviously it's sometimes difficult because they lose context. So you would need to instruct the synthesizer or the orchestrator to always make sure the synthesizer gets all the relevant context, because there is these calls in between. Now we come to actually a very interesting one, where in my opinion it starts to get more agentic, because we have actually not just one direction of flow, but we can go forth and then go back again. So typical example of this is the evaluator optimizer, which I recommend to use. It actually creates extremely good results because you are able to basically gate a certain output based on a template framework. So let's say the example for the copy again, you have one LLM that creates a certain copy, and so it's in a way a solution that is delivered to the evaluator, and the evaluator has a specific framework based on, let's say, the hook, the psychological triggers, the alignment with the brand identity, the relevance of the content in the context of current news, and then it gives a rating from 1 to 10, and you have it instructed to only accept if the rating on average is over 9. And so if the rating comes out at 8, it will actually send back the copy to the LLM call generator and tell it, hey, this is not good enough because, I don't know, for example, you didn't nail the hook, so please revise the hook. And this will go on cyclically until actually it's able to accept. And there is the danger of loops here, obviously, because if the threshold, the benchmark is too high, they will just keep looping and not getting results better. So it's tricky to get this right, but definitely, so I would probably define a max number of repeats until when it goes, it actually gets accepted. Yeah. And let me see. Actually, what I would do now is, before we continue, what I want to do is demonstrate another use case for Luna, which would be this, for example. So I will give her a different kind of request. I will tell her, hey Luna, I am currently deep diving on an article by Anthropic regarding agent development and the difference with workflows. I want to use this as base and develop a detailed, let's call it ebook around my style of development merged with the specific input from the article. Before I give you the input, I have a planning task for you. In order to get the best possible juiciness out of the article, please check what tools you have at your disposal, what tools and sub-agents you have at your disposal to build on the content of the article and extract a solid conceptual framework that I can then take and further expand with my own thinking. Please deliver the plan first for my review before proceeding with implementing it. So you see here now, this is a very different request that I gave to Luna, who just, so the request is very different because in this case, I'm not telling her what to do. Or I'm telling her what to do, but it's actually on a different level of abstraction. So when I tell her transcribe the article, she already knows, okay, it's a transcription task. There is no optimizing on the level of decision making. But now there is actually a decision making component, because on the planning side of things, and this is where actually, and I'll do a video about it, the thinking agents O1 and DeepSeek, etc., R1 come in handy because they're very good at planning. So what you would do is you would give them the planning task and then have a non-reasoning agent basically do the execution. You wouldn't have the thinking agent execute, you would have the thinking agent think and the non-thinking or the normal LLM execute. But in this case, Luna is powered by Sonnet 3.5, so it's already a decent LLM. We'll just give her this planning task and see what she comes up with, right? So she will need to think. I gave her a goal, and this is written still, in a very fluent way, but I like to demonstrate how a normal user would write it. If I would write it, I have a tool for, specific prompt structures. But I think for demonstration purposes, it's always better to just write it how a normal user would write it. And so let's see what she comes up with. Oh, what's happening? Yeah, should work. I don't know. There was some loading issue, but let's see what she comes up with, right? Look, so now she's actually not executing anything, but she came up with a plan. So I help you create a comprehensive plan to analyze and build upon the Anthropic article. So what is she suggesting? Available tools and strategy. Okay, so first, great, she suggests, what is happening here? This mouse is a bit broken. But first he's suggesting to extract the content, right? So we don't miss any crucial points. Then what she's suggesting, because we have a company researcher, to actually research the context a little bit better. An interesting one, right? So the company researcher is actually a sub-agent that is able to access Google and also scrape websites. So it can just give a more research-oriented task. And she says this will help position the content within the broader industry context. And then, only then, it suggests to actually write the copy. So this is very good, right? It's a planning task. So I didn't ask her to do anything, but I asked her to plan. And this is where agents and the power of agents really come in. And because they have cognitive power, and this is the thing that the biggest mind shift in my development is always to think, okay, these things can really think. And so I need to ask differently, because otherwise they will just execute. Like before she just executed. She just transcribed and gave me the key points. Now I ask her to think. So I also need to think now on her thinking and be like, okay, do I like this? Is this the right approach? And obviously this is a very easy task. I just did for demonstration purposes. But basically, you see that she came up with a plan. And now I could change the plan, I could tell her, okay, on the research enhancement, I want specific angles to be researched, specific subtopics, sub-niches to enhance my thinking. But we won't do this now. But this is just to show you that prompting makes a huge difference, and especially co-thinking and seeing agents as sparring partners rather than just execution and workforce is what makes the real difference. Because if you just need something or someone executing, workflows can do a lot of the heavy lifting. But if you want to think across a different level of abstraction, then agents can come in really handy. And then let's see, content extraction analysis. Yeah, I love how the estimate time is based on like human time. Because it's like, yeah, she will just take, a few seconds. But it's funny, I noticed that the LLMs base their time estimates for work on human hours. So you also see how long it will probably take for a normal person, a whole work day, and Luna will just do it in a few minutes, And so now, if you continue, you see that the URL of the Anthropic article, she's obviously asking, she's missing stuff, and then she would be able to continue. So now, we could tell her. So maybe we do the example. Hey Luna, this is great. I have one critical addition that I need your thinking on. For step 2, the research enhancement, I would like to explore 2 angles, 2 different angles. And now let's just give it an open task. So why I like your suggestion to use the company researcher twice. Can you suggest 2 angles? Please send me the revised plan. Yeah, and this is very random because I'm asking her different research angles. I asked her to come up with 2 different research angles. Normally I would tell her, because we are AI enhanced thinkers, and so we don't substitute, but sometimes she might come up with something original you haven't thought about. So this is again where the sparring partner approach comes in, where I'm like, I need to think now and be like, okay, I want to research this more in depth, but then she can think about how, and let's see what she comes up with. Let's see, phase 2. Previous phase 1 remains the same, dual angle research. Okay, great. So you see, so 1 is the technical and methodological research. Anthropic's technical approach to AI agent development, and the other one is implementation market impact, so more on the actual market and implementations of agents and workflows. So yeah, these are actually two interesting angles, right? And now especially the second one is cool because I can also add my own real world experience, while on the first one, as I'm not with Anthropic, she can do some research. There is a lot of content out there and developers, sharing their experiences. And then we continue. So you see 8-9 hours, a whole work day, and probably, yeah, it would take that, if not longer. And now you just compress it in, maybe an hour if I wanted to do this, right? Maybe a bit longer, maybe 2 hours. I like to take my time and think through things, so I wouldn't recommend, I wouldn't recommend seeing this as a workflow and just get things done. Obviously, you can get them done 100x faster, but if you get them done, 20x faster is still way faster, and then you can also go deep. Cool. So let's continue here in the article, the workflow evaluator optimizer. This is a very good one. I tried it also with Relevance. It works quite well. You can have an agent loop through a certain benchmark to improve the actual output, and have the gatekeeper then decide whether to continue or not. And now come actual agents, right? So up to now, as we've said, it's more of like a focus on worker workflows, which are more predictable and based on a certain input-output framework. But you already see how much can be done here, right? So this is actually where most people already define these as agents, and you could, but in the end they are actually specific workflows. And now the agents come in, and this is where it gets very interesting, because agents are very different, right? They are able to really understand complex input and engage in reasoning and planning. They use tools, and they can recover from errors. This is a very interesting one. So they're able to look back at what they did and reflect on that as well. And you see, now we are introducing a different concept, an environment, which I also like to call state of the world, which is basically a reference information point that the agent has, which gives automatic feedback based on a goal or a certain ideal environment to the LLM, who will then take action on it. So it's actually changing the environment and getting automatic feedback from the environment, and then deciding whether to change anything again. And you see, when to use agents can be used for open-ended problems where it's difficult or impossible to predict the required number of steps, and where you can't hard-code a fixed path. The LLM will potentially operate for many turns, and you must have some level of trust in its decision-making. Agents' autonomy makes them ideal for scaling tasks in trusted environments. So you see why agents are very difficult, different, because you have an environment aspect. We didn't have an environment here. So this is a little bit like an environment check where you get a certain feedback. But other than that, you really just have an information flow, input, output. You don't have the synthesizer now, checking outside environment, or maybe, actually I would have to put it like this. You don't have the synthesizer putting out a certain information, and then actually the information feeding back to the orchestrator, who would then decide whether to run this process again. That's not possible. Once it's run, it's done. So it's triggered, the information flows from left to right, and then the workflow is done. Here you have a certain aspect, of evaluation, but again, once it's accepted, it's out. There is no turning back. While here, it's an iterative feedback loop. It can loop as many times or as few times as required. And this is where agents come in really handy. And so you see here, for example, how a typical flow of a coding agent is. which is, it looks more complex than it is. But imagine, you're using Replit. I don't know if you've used Replit. It will basically ask you to give a prompt. Then you give it through the interface. It will reach the LLM, and the LLM will then start developing the website for you. So the website is kind of your state, your environment, and so it will start basically based on the instructions, start writing code until certain tests are passed. So it will write code, send back a status, test it again, send back status. So basically this aspect. And then once it feels like it's done, it will go back the whole way to the human and give it certain feedback, and then the human can start the process again. So it's very cyclical and dynamic, and it's impossible to predict what the human input will be, and at the same time what the environment feedback will be. So this is where, in my opinion, the real agentic reasoning comes in, where you create basically a loop of work that can dynamically get things done, but you cannot really predict where this is going. So it could go in either direction. The website could be great at some point or be a total mess. But then still the work would have been done, right? So that's why it's so important that you have, I see these days, actually human component, at least for what I do, because otherwise if you let the agent run loose alone, it can quickly go in the wrong direction. So yeah, actually thinking whether we can somehow demonstrate this here, but not really, because Luna doesn't have an environment variable, right? In the sense that there is nothing for her to check and work towards. In the sense that, yes, now we have obviously defined a certain plan and procedure, and now I could tell her to just do it, and then it's done. But she's not able on her own to check whether it's done in the sense, right? Like she wouldn't be able to use tool A, tool B, tool 3, and then send me the result. She wouldn't be able to use the tools, then evaluate the results, and based on a certain, here test, decide whether the results are satisfactory or not, and then basically keep working until the results align with my request. It would be possible if I would include an environment where she would, for example, put this to a certain content calendar, or a certain, if I had a certain framework or environment where I tell her, okay, these parts need to be filled. For example, let's say this is just the input for a detailed outline with 10 parts that need to be filled. And now she does all the research and she fills 5 parts. And then she will be able to check against this test that all the 10 parts need to be filled, and be like, okay, wait, it's not filled, I need to go back. And then once she comes back, she can tell me, okay, I did all the research and actually the whole outline is filled. Cool. So yeah, let's wrap this up. So success in the LLM space isn't about building the most sophisticated systems, although it sounds cool, but it can get messy quickly, and it's about building the right systems for your needs. Start with simple prompts, optimize them with comprehensive evaluation, and add multi-step agentic systems only when simpler solutions fall short. So maintain simplicity, prioritize transparency, and carefully craft your agent-computer interface, which is all, I like the maintain simplicity. For me, it's the most important aspect in agent design, because really this is where the magic happens. The simpler, actually, the better. You consume less tokens, you really understood the problem and what needs to be solved, and are not just building a huge system because it's kind of cool. although it is cool. I like to build huge systems. Um, yeah, yeah, cool. I think we're done. So I just wanted to, briefly walk you through this paper. I can very much recommend it. And if you like this, I continue to do a little series about, technical or semi-technical aspects of agent development.